In this video, we are going to summarize the formula for instantaneous speed and acceleration. So this is a recording of a moving puck, position M1, M2, M3 at instants T1, T2, and T3 respectively. So to find the instantaneous speed of M2, we need 2 points, one before and one after. So the speed at position M2 is the distance M1, M3, a point before, a point after, over T3 minus T1, which is the duration needed to move from M1 to M3, and AM2, which means the acceleration at T2, is equal to the speed after minus before, so Vm3 minus Vm1 over T3 minus T1. Now with direct application, document 1 shows the registration of a puck A on an inclined airtable. A0, A1, A2, A3, A4, A5, A6, A7 are successive positions that are recorded between equal time intervals. So the time interval between two consecutive dots is called time constant tau. In this case, it is given to be 0.1 seconds. So part 1 indicate with a justification the trajectory described by the puck. Part 2 calculate the average speed of the puck in meters per second. And part 3 complete the following table, which requires you to fill in the instantaneous speeds and acceleration as you can see at each position. So starting with the first question, indicate with justification the trajectory described by the puck. The trajectory described by the puck is rectilinear since the dots are collinear. So if you combine the successive positions of the puck, they form a straight line. Calculate the average speed of the puck in meters per second. As long as we did not specify an interval of time, this means you have to calculate the average speed for the whole motion from the beginning to the final position given. So you have to count the distance from A0 to A7 is equal to 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 centimeters over the time between one position and the successive one. There is tau, so it is 1 tau, 2 tau, 3 taus, 4 taus, 5 taus, 6 taus, and 7 taus. 7 taus means 7 times 0.1 seconds, so 0.7 seconds. It's equal to 50 centimeter per second, which is equal to 0.5 meter per second. Now finally filling in the table to calculate the instantaneous speed and acceleration. So why did we cancel this part for A0? Because we have no information about the position before this time, so that's why we cannot calculate the instantaneous speed for A0. Now for A1 we have enough information before and after, so it is the distance A0, A2 over 2 tau, and it's 5 centimeter over 0.2 seconds because the time from A0 to A2 is tau, 2 tau. 25 centimeter per second. Similarly for A2 it is A1 A3 over 2 tau, which is 7 centimeter over 0.2 seconds equals 35 centimeter per second. And you have A2 A4 A3 is A2 A4 before and after, so the distance from the position before till the position after it over 2 tau, 9 centimeter over 0.2 seconds equal 45 centimeter per second, and so on. Similarly for A4, A5, and A6. Now for A7, why we cannot fill in or calculate the instantaneous speed at A7? Because there is no information about the position after it. So whenever we want to calculate instantaneous speed or instantaneous acceleration, we need information before and after. As for A, for the acceleration, similarly, so at T0 we don't know the speed before this position, so that's why we cannot calculate it. For A1, at A1 also we do not know V0, so that's why we cannot calculate it, because A1 should be V3 minus V0 and we couldn't calculate V0 here, so that's why we cannot calculate A1. Now A2, it's equal to V3 minus V1 over also 2 tau, and the result is 100 centimeter per second square. V3 or A3 is equal V4 minus V2 before and after over 2 tau, and so on till we reach position 6 and 7. Similarly, if you want to calculate the acceleration at instant t equals 6, we need V7 and V5. We couldn't calculate V7 here, so that's why I cannot find A6. And similarly for the acceleration at T7, I need a V8 and V6, V8 after it and V6 before it. So V6 is given, but we don't have any information about the position after A7, so we cannot calculate the instantaneous acceleration at T7. So now converting the obtained values to the SI unit in centimeter per second to meter per second and centimeter per second squared to meter per second squared, we have to divide centimeter per second by 100 in order to obtain it in meters per second. So 25 becomes 0.25 and so on for all. And from centimeter per second squared to meter per second squared, also we have to divide by 100, so it becomes here 1 meter per second squared.